In today's world, urbanization has led to increased travel demands, and emissions are deteriorating the quality of our cities. It has become imperative to change the urban landscape to better suit the needs of sustainable modes of transport, such as walking and cycling. The common issue is there's no connected or continuous protected cycling way. Unprotected bike lanes are common, with width that varies and sometimes impractical, falling below the best practice standards and providing little separation from the traffic. From observation, narrowing the cycling lane creates pinch points and hinders the experience of cycling. It causes drivers to unintentionally pass closely, which is dangerous and intimidating for newer bicycle users. Although using a buffer can alleviate the issues, one drawback with unprotected bicycle lane is that they just simply painted, which does not stop people from parking or moving on them. Using these projects, we want to address improving the experience of cycling within the urban environment by using the site surrounding Swinburne campus and applying proposals to the physical infrastructures in order to create a dedicated, continuous cycling route. We use pet catch analysis to evaluate accessibility and travel time across the campus context. Pet catch allows us to visualize the maximum travel time from the campus entry points, helping us understand how far and how quickly cyclists can reach different destinations. In addition, pet catch allows us to identify areas where steep gradients and physical barriers significantly slow down cycling movement. By mapping these conditions, we are able to select and propose optimal routes, improving both travel efficiency and user comfort. We use time-flow pathfinding simulations as a design tool to understand the movement dynamics of cyclist circulations. By using time-flow, we simulated the velocity and travel behavior of cyclists across different route scenarios of the street network towards Swinburne campus. The simulation not only reveals optimal pathways, but also highlighted bottlenecks, unsafe crossings, and potential conflict with other vehicles and trams, which inform our proposals for the next stage. As a result, we have picked up 3 types of road that represents different scenarios that hinder the cycling experience around campus. The first one is Clanferry Road, where cyclists have to share with multiple modes of transport, including trams, cars, cyclists, pedestrians, and parking bay, all sharing the same narrow space. It shows that most of the issues that cyclists have to face in urban environment, they all appear in Clanferry. This overlap creates a series of conflicts, particularly for cyclists who must travel between moving vehicles or ride along the footpaths, leading to unsafe conditions and slower travel time to the campus. We have started by redesigning the Clanferry street sections by moving parking outside for physical separations. This design places the bike lane next to the sidewalk, with parked cars acting as physical barriers against traffic, reducing crash risks up to 53% when using low-cost delineator. In addition, we apply multiple micro-scaled urban design solutions to generate design interventions, including dealing with the conflict points by designing a tram stop. The use of sensor lights and changes in surface treatment respond to kinetic sensors. Adding street furniture enhances the visual richness, and equipping cross-section with planting strip makes the surrounding more The first attempt is mostly application of urban design qualities through the use of various street elements that prioritize the safety and the overall experience of cycling. During our research on Burwood Street, which is a typical vehicle-dominated road, and our proposed additional neighborhood street that connect directly to Swinburne campus, which is the whole street, they are all prioritizing cars over bicycles and opposing cyclists to high-speed vehicles, which is dangerous. In this stage, we were inspired by precedents of elevated cycling paths in Copenhagen. This elevated bike path not only enhances efficiency, but also reflects people-centric vision for the future. Building on this, our project further proposes a green spine that passes through key intersections and connects directly to Swinburne campus. By lifting cyclists above traffic and tram lines, this design eliminates conflict points, reduce travel times, and offer a unique elevated experience of movement for the cyclists. In a similar approach with local road, we turn the street into cycling central area by narrow the double lane into single lane and gate bypass on either side of the road. The vehicles are diverted above the belt around to fully and safely divert traffic across cycling intersections. This design ultimately provides a safe space for cyclists around street intersections and make their journey to Swinburne campus safer and more efficient.